some are have the camera way too far away from the document. So when you try to zoom in, you can't zoom in far enough when I'm grading. Some are blurry, like you're not holding the camera still. And others are just very, very dark. Like you need to turn more lights on in your room because if you see me using a yellow font when I'm doing any comments, when you're getting after you've gotten your assignment graded, that means it's way too dark. I should never have to use a yellow font to make the text visible. So before you submit your PDF, open it, look at it, and make sure you can read it. Because if you can't read it, I can't read it. And if I can't read it, I can't grade it. Okay, so take a little more effort. I mean, these are isolated instances, but I'm starting to see a little more of them as the semester goes on here. So keep that in mind, okay? Okay, so today is a fairly simple exercise. If we were going out to actually take these measurements today, this would be the shortest lab of the semester as far as time is concerned. You'd probably be out there for maybe 20 to 30 minutes because you're only measuring 4 angles. So it's going to go pretty quick, as is the assignment. There's just the assignment itself is very simple. So this should be an easy week for you, okay? So what we're going to do today, the goal today is for you with some known data that you've already measured and some additional angles that are being measured in this lab. You'll be able to, with a couple of calculations, to calculate the elevation of the top of the west tower of the Guy West Bridge. Okay, so I think we can kind of bypass the first photo here. This is just circling the same location we've been working most of the semester. But let's go to the next photo. The lab manual instructs us to set up at points A and D. Well, when that lab assignment was created, that worked fine. However, now the trees have grown taller, and if you set up on points A and D instead of points E and F, you can't see the tower from point D because the trees are in the way. You can barely see the tower now from point E. So I don't know how much longer we're going to be able to do this lab without, somebody going out and trimming some of these trees. That's the only solution. But you can see that there's a triangle here from the tower down to points E and point F, and I'll go over that in a minute. Today, you'll be calculating a distance based on some angles you're measuring. You'll be calculating a distance from point F to the tower and point E to the tower. Okay, I want you to understand the proximity or the range of that distance, because if that distance isn't correct, you're going to have a really bad answer for your elevation for your tower. So just, I'm not going to go back and show the picture from last week where it shows all 6 points A through F with the 6-sided traverse figure, but keep in mind, just from, I'm looking at our Lab 8 data, we know the distance from E to D is about 250 feet. And we know the distance from D to C is 330 feet, okay? Now, you're gonna have to kind of visualize how far you think it is from point C to the tower. In other words, don't give me an answer of like 150 feet for that total distance. You know right now it's going to be a minimum of 248 plus 331. Okay, so 579 feet. Okay, so before you submit this, check to make sure your answers make sense. So just keep that in mind when you're calculating the distance E to F or excuse me, the distance E to the tower and F to the tower. Okay. Next is the data. Okay, let's do one more photo here. Here is looking at the top of the tower from up the hill on point F. Obviously, you can clearly sight the top of the tower with the total station. But when you go down to point E, you can barely see it. That's what I was referring to a second ago. If those couple trees grow higher, we won't be able to do this lab any longer. Okay. If you have any questions along the way, just speak on up. Okay. So now here's the data that you're going to assume you went out and measured today. Okay. Let's just kind of read through this. Total station setup. So you're going to set up today at both points, E and F. And in order to calculate the elevation of the tower, you're going to need the elevation of points E and point F. So you're going to have to go back to lab 4 and get those adjusted elevations that you calculated when you did lab 4. Okay, those are the elevations you're going to use for points E and points F. Okay. You're also going to need the horizontal distance between points E and F, and that's from last week. I'll just give that to you right now. E to F is 67.683 feet. And that's right on your assignment you submitted last week. So verify that. But that's the distance you're going to use between E and F. Okay. So today, you'd be going out, setting up on points E and F. You'd be measuring one horizontal angle and one vertical angle at each of the two setups. Okay. And I'll be going through that with the next PDF that I'm going to show, and again on the whiteboard. The HI they're referring to here is a little different than the HI that you use the leveling. It's just a different interpretation of it. The real definition of HI is the elevation of the instrument above sea level, the actual elevation of the instrument. HI in this case is the distance from the point on the ground to the center of the total station. That's the 4.83 at location E, and that's the 5.23 at point F. So you do need that to calculate the elevation of the tower too, because you're going to add the height of instrument at each setup to the ground elevation at point E and F. And we'll Okay, could somebody confirm the audio is coming through now after we got disconnected?
It works.
Okay, and it was working prior to that cutoff there, wasn't it?
Yeah.
Okay, all right, well, I've lost my video here, so let's see what I can do. Looks like I'm gonna have to go back and log in again. The joys of modern technology. All right. And you'll notice I do have to go in and change the due dates from these labs now, because obviously this assignment's not due until next Monday. Okay, I think we were done looking at CE9 exercise 11 PDF. So I'm going to go to the sample that we're going to use today. This is the photocopy of the sample from your textbook of this problem. So here's sort of a bird's eye three-dimensional view. And I'm going to point out something that you need to write down and you need to understand, okay? We're going to use the same nomenclature and the same variables that this sample problem in the textbook uses. Notice, however, they're measuring to the top of a smokestack and we're measuring to the top of a bridge. That's irrelevant. The math is all the same. So the only difference I want you to change is that wherever you see the letter A, which refers to the point furthest to the left, or in our case, furthest down the hill, I want you to change that letter A to letter F, or excuse me, letter E. A becomes E because we're setting up on point E. Okay, so HI sub A becomes HI sub E. Okay, at the tower, distance IA becomes distance IE. So wherever you see an A, change it to an E. The same thing up at the top of the hill in this problem right next to the road where point B is. That, in our case, is point F. So change point B to point F and everything you're looking at here. And I've already done that on the sample problem on the next page that you'll see. All right, everybody understand that. Don't use A and B, use E and F, okay? So you can see here that at point A, they're measuring a vertical angle called V sub 1, and I think we're calling it V sub E. I didn't write that down, but that's just on the last page we were looking at before the Zoom cut out, okay? And you can see angle A, the horizontal angle, that would be angle E. So you've got a horizontal angle and a vertical angle at each location, A and B. When I draw this on the whiteboard, because I can't draw this concisely and clearly in 3 dimensions, I'm going to break it down to the horizontal part of it and the vertical part of it. Okay, so questions on what you're measuring here. You just are measuring a vertical angle at each location, E and F, okay? And a horizontal angle at each location, E and F, and the height of the instrument at both locations, E and F, okay? Before we go on a little bit, I want to talk about how the instrument works when you're measuring vertical angles. There's no setting angles to 0 like you did with the horizontal component of it. When you turn the instrument on, you'll see the first immediate thing you'll see on the screen is it'll say tilt telescope. And what that means is you just grab the telescope and you rotate the vertical axis a little bit in each direction, and that orients the vertical circle in the telescope to know where 0 is on the vertical circle. Okay. I'm not going to go into the specifics on the instrument and how it works, but just understand that the vertical angle that you're reading in the screen is based on the angle 0 in a horizontal plane. Okay, so in other words here, the line, the dashed line that goes from the top of the tripod at location A over to the bottom of the telescope, that dashed line is a horizontal line. The same thing with the solid line here that goes along the ground from point B to the bottom of the smokestack. Okay, that is a horizontal line, as is the line directly above it from the top of the tripod to the telescope at location I sub B. Okay, so the bottom portion of your vertical angle is always in a horizontal plane, and the vertical angle, as you can see here, is the angle directly above with the horizontal line at the bottom. The bottom leg of the triangle is horizontal. Okay. All right, so let's go through here, and this just describes the whole procedure. So horizontally here now, because you have a horizontal angle at point F, a horizontal angle at point A, and you've got your horizontal distance, E to F. That's the distance that I just gave you of 67.683. All right. So with those two angles and the one distance, using the law of sines, you can calculate the distance, the horizontal distance from the instrument to the bridge. And that, you can see the sample formula right there. That's formula 11.42 and 11.43. Those will permit you to calculate the horizontal distance from points E and point F to the bridge tower. Okay. Vertically, in order to calculate the top of the tower, we need three distances. One, and I already mentioned this, the elevation on the ground at point E and F, and the height of the instrument above the ground on the tripod at points E and F. So knowing that, and in order to get the distance at the tower from IA at the bottom to the top of point P and IB at the bottom to the top of point P, you just take the vertical angle that you measured. Look now at formula 11.44 and 11.45. You're taking the vertical angle, the tangent of the vertical angle that you measured times the distance that you calculated up in the prior two formulas. Okay. Then to get the height of the tower, you just add everything together. You're going to have two calculations. Since we set the instrument up twice, we're going to use the calculations from both locations. Use the calculations and the measurements from both locations, and then we're going to take the mean of those two, and that will be the elevation of the tower. So we've got the distance IAP, which is the distance from the distance that you calculated vertically. No, it's not. That it is. Yeah. Okay. Yeah. IAP is that vertical distance. IAP and IBP, taking the tangent of the angle times the distance you calculated for each AI sub A and BI sub B. Okay, then you add the elevation on the ground and you add the height of the instrument at both locations, and then you divide that by 2, and that's your elevation at the top of the tower. Okay, questions on the math here? So you're doing one distance calculation based on your angles that you measured. You're doing 2 vertical distance calculations with the horizontal distance times the tangent of the angles, and then you're adding all that data together in the bottom. Okay, now on the next page is the actual problem with the sample data in the problem. So remember, I've changed here now. I've crossed out A and B and put in E and F. Make sure you do that when you are preparing your assignment. Realize here, though, that the sample numbers that they're using, in other words, the HI of 5.55 and 5.48 at the top, you're not going to use those. You're going to use the HI that were given on page 3 of exercise 11.pdf that I showed you before the Zoom meeting went dead. Okay. Same thing with angle E and angle F. You're going to use the angles that were given to you, okay, and the vertical angles. Don't use the data here in this sample problem. Just use the formulas in this sample problem. And if you get confused, everything is spelled out right here. You just have to substitute your numbers for the numbers in this problem, and you should have no problems calculating the elevation of the bridge tower. Okay. So any questions what you're doing here? Earlier I discussed making sure that your distance that you calculate from your 2 points E and F to the tower makes sense by knowing the 2 distances from lab 8, from E to D and D to C, and then the short distance you're going to have from point C to the bridge. Okay. The same way, make sure that the elevation of the tower that you calculate makes sense. If you get an elevation 2,000 feet tall, that's incorrect. There's no way that bridge tower is 2,000 feet tall. Okay. So just use a little common sense and looking at that, and make sure that the elevation of that tower is reasonable. Okay. Please do that, because I've seen some crazy numbers over the semesters. And if you just go back and review your work, you'll find your error. Okay. So make sure that that distance that you calculate using the law of sines is reasonable, and make sure the height of the tower makes sense. Just go back and look at the photos that were taken in the previous PDF showing what the tower looks like standing at point E and standing at point F, and kind of gauge, okay, is my answer reasonable looking at this photo? Okay. And that is it as far as the formulas and the variables and the data that you're going to be using. Okay. So any questions what we've done so far? Okay, I'm just going to quickly draw this on the whiteboard and just break it down into the horizontal component and the vertical component of it. And before I do that, I want to take roll here and see who's missing. Okay, there is somebody that's late again, and that person has dropped. And Abraham Ibrahim, okay, you're here. And you're late again, too. Okay. So let me go to the whiteboard here. And I'm going to start with the vertical component of this. So here's the bridge. And here's the bike path. And here is the tower, West Tower. And over here is your manholes that you worked with when we were leveling, okay? And so we've got point F down here, and we've got point E over here. Actually, let's draw the tower over here. Okay. All right, so let's start when you're at point E, okay? When you're looking at the tower, I'm just going to draw a little diagram here. So the tower, you're going to be looking at the side of it, and at the top, there's this little rounded bracket that holds the cables in place as the cables cross over the top of the bridge. And you're going to want to aim with the telescope, the crosshairs in the telescope, to the top of that bracket and to as near to the center of that bracket as you can. So that's what you'd be looking at if you were going out and taking that measurement today. Okay. So you're set up on point E. You're going to backsite the tower just as I showed you over here. Okay. And you're going to take your vertical angle reading first thing. And I'll show you that in a second. We're only looking at the horizontal component right now. Okay. So once you're backsighted on the top of the bridge tower, remember that this line, the vertical line, projects all the way down to the ground surface. So don't worry, just because you're aimed way up in the air, that the vertical axis and the horizontal axis are independent of each other. You don't need to actually sight down here at ground level to turn your horizontal angle. You're already in the correct plane, okay? So you would, after you have recorded your vertical angle, you turn your clockwise angle to location E. So you have a back sight here and a foresight here, and this gives you angle E right here. Okay. So you've got your vertical angle over here. You've got your horizontal angle right here. And then you're going to measure the height of the instrument with a tape measure from the ground up to the middle of the telescope of the instrument. And if you were doing this lab today, you would also measure the distance from E to F. Okay. Then, any questions there on point E? It's going to be the same procedure. Located over here at point F, except the sequence is a little different. Okay, at point F, you're going to backsight point E. All right. Then you're going to turn the horizontal angle when you're sighted at the tower, like so here. Okay. So you'll have angle B or angle F measured here. You'll have a foresight here, a backsight here. And you will also then take a distance back from E to F, and you'll measure the height of the instrument here. Okay. Now, knowing this distance and these two angles, you can calculate these two distances. All right. So any questions horizontally here? Okay. Actually, I'm just going to clear the whole thing. All right. Now, vertically, it's quite simple. You've got the bridge tower. Looks something like this. And then you got the ground surface, which is fairly flat. Okay. And because, and then we have point F here at the top of the bike path. I'm not going to draw point E because it's going to get confusing, but just realize you're doing the same thing at both setups, E and F. Okay. So you'd be set up if your point is right here. You'd have your instrument set up over your point. Okay. And your vertical angle would begin along this horizontal line here. You turn the telescope and aim up to the tower, and then you would read your angle right off the instrument. Okay. There's no buttons to push. Once you turn the instrument on and you tilt the telescope, the instrument is oriented to where it needs to be to give you the correct measurement. So just look for angle VA in the window on the total station, and that would be this vertical angle here. Okay. So now you've got your elevation from lab 4. You've got your height of instrument that you are given today of 4 point whatever or 5 point whatever feet. That gives you your elevation here. And then you've calculated this distance and you've measured this angle. So tangent of this angle times this distance gives you this distance here, which you would then add to the distance here. It just calculated with the elevation plus the HI plus this distance. Those are the three numbers that you add together to get the elevation at the top of the tower. Okay. Any questions on the vertical part? Okay. This should be fairly quick to do. These calculations are going to be since you've been given pretty much, just plug in your numbers into that sample problem and you're done. Just make sure you do it correctly. So as far as what you're submitting to be graded, if you look at the lab manual, you're on figure 11-1, you've got your typical information on the right side of the page. Again, the equipment this week is total station. And on the left side is where you're going to show all your work for doing all of your calculations. Okay. Completely disregard all the variables and all the numbers that are shown in the lab manual, because we've changed everything because of the handout for the sample problem from the textbook. That takes the place of the sample problem in the lab manual. Okay, everybody understand that? So you're submitting figure 11-1, and that is all. You don't need to draw the fancy picture in 11-2. This will be it, just 11-1 this week. Okay. This will be the last assignment. If we were not doing virtual meetings this semester, this would be the last week you'd be going out with any equipment to do any measurements in the field. The rest of the semester, all of the assignments are going to be what we call paper labs, dry labs. And the reason we do that, I think I mentioned, is that we don't want to have a field lab for every exercise because normally we'd be encountering some rain by now, but we haven't. So the rest of your assignments, I don't believe will be done on your blank lab note sheet that you've been using all semester. It'll be just done on regular 8.5 by 11 graph paper. Okay. So any questions on anything you're doing this week? Okay. I have nothing else. So if you have no questions, feel free to log off. I will change the due date for the assignment to allow you to submit your lab this week. Okay. As we know with Canvas, after a certain duration, after the due date, it won't let you submit anything late. So I've got to change the due date to allow you to submit. Okay. So if there's no questions, we will talk again next Thursday.
Thank you.